Hello everyone, thanks so much for joining. We will just let a few more people join in and then we'll just jump right in. And thanks for joining everyone. Welcome to our webinar, Achieve Near Real-Time Analytics on Amazon DynamoDB with SingleStore. My name is Yukti Divedi and I will be a moderator for today. One of my main jobs here at SingleStore is to organize weekly AI webinars. We organize two, maybe three webinars per week. So if any of these topics are interesting to you, that is there on your screen, feel free to connect with me or anyone from the team to stay on top of the loop and to see your feedback, your ideas on future sessions. So feel free to drop a message on LinkedIn. Speaking of future sessions, we've got multiple informative new webinar sessions that are coming up. Tomorrow, on back on popular demand, we have Beginner's Guide to RAG Evaluation with Professor Tom Ye from Colorado University. So this is a very popular session and is one of our most popular events. So it's a must attend. So, and on August 29th, we have how to use SingleStore for auto scaling. So it's a pretty hands-on session and it will be done by an expert on the particular topic. So if it's interesting to you, feel free to RSVP right now. And on September 5th, we have how to talk to your SQL data with function calling. So if any of these topics are interesting, RSVP right now, and I hope to see you all there. Coming back to today's topic, you're welcome to participate in the discussion throughout the session using the Zoom Q&A button, which is present at the bottom of your console. We have an internal mission statement to try to answer 100% of the audience questions online. And if that's not possible, we also follow up with folks afterwards via email. Uh, no matter what your question is, just make sure to ask away. Just make sure that you have logged into Zoom with your actual name and email address because we will not be answering any anonymous questions. So moving on to the next slide, we would like you all to have a dynamic experience during this webinar. So feel free to try out SingleStore notebooks. Anyone who tries it today will be entered for a chance to win either branded new AirPods Pro or Meta's new Ray-Ban LLM smart glasses. It's absolutely your choice. Simply click the link that's present on your screen or maybe just scan the QR code. It will take you to a landing page to the free cloud trial. You can actually follow along during the session so that you have a more of a hands-on experience. And our speakers will do the best to help you in case you have any questions. So you may know that SingleStore has had a free trial offer for many years, but just in the past few weeks, we have also announced a new free share tier today. So we'll talk about a bit later today. So you might have noticed that we also have an auto RSVP to our future AI webinar option on our website. So if any of these topics are interesting, just feel free to checkbox the auto RSVP feature, which will auto register you to the upcoming Zooms, and it will just add it to your calendar, which you obviously don't need to attend, but this is just an option for those who have requested to automatically receive the video recordings and the GitHub links, which are useful for the session. Moving on, allow me to introduce our amazing speakers for today. We have the real experts today joining us is Ben Paul, who is a cloud solutions engineer here at SingleStore, and Saurabh, who's a senior partner solutions architect at AWS. Both of the speakers have had extensive expertise and very strong background in everything data related and have been phenomenal in providing enterprise solutions to their customers. Very happy to have you here. And we also have Akmal, who is there to assist you with the Q&A. Thank you everyone for joining. And Ben, now I would like to hand over the mic to you.
Great, thank you very much. Thank you everyone for joining. So today's webinar is obviously, as the title suggests, about sort of using DynamoDB and SingleStore side by side to get real-time analytics, or to be able to serve up real-time analytics to your customers on your Dynamo data. So sort of the flow we're going to go through today is I'll do a quick overview of SingleStore, just very high level, not too much in the weeds, just so those who are unfamiliar with SingleStore get an understanding. I'll then pass to Saurabh. He's going to do an overview of DynamoDB, a very brief one. And then he's going to go into two design patterns that we use in production for our customers who are trying to achieve this pattern where they're using DynamoDB for their transactional system, and then they're using SingleStore for their near real-time analytics that they're serving up to their customers. So once we go through those two design patterns, I'll run through a demo on one of the design patterns and just show you how easy it is to set up, and then just a very, very quick look at how you can do the analytics in SingleStore, or rather the query syntax. So that's the flow for today. I'll kick it off with the SingleStore overview. So just for those who are unfamiliar, this is really the history of SingleStore, where we've come from and where we're at now. So we were founded in 2011, and we were founded with the name MemSQL. The reason being, the goal at that stage was to be the fastest in-memory OLTP database. And we launched that in-memory OLTP database in 2012 and then went GA in 2014. Now, about halfway through 2015, we also added an additional table type, that being our on-disk columnar store. So at this stage, we had an in-memory row store, which is great for transactional processing. And then we also had an on-disk columnar store, which is great for those analytical queries because you get the compression because the data is stored in the columnar format. Fast forward around to early 2019, and two big leaps were made. The first was we released our patented universal storage, and this combined our two table types. So it combined the in-memory row store with the on-disk columnar store. Because of this unified table type, we're now able to, in one table type, achieve both good performance on transactional workloads, so those point read and writes, but also take advantage of that columnar store and get really fast analytical performance. So this was a really big switch for SingleStore, where we merged those two separate worlds of transactions and analytics into one table type where we could handle both. And along with that, we released our Helios cloud service. So prior to 2019, we were purely a self-managed offering. But now we had both the self-managed offering and the managed service offering, which we called Helios, giving our customers the flexibility to meet them where they are. Fast forward into 2024, we now have over 350 customers and over $100 million in annual recurring revenue. So it's a really quick overview of where we've come from and where we're at. So I'll pop over to the next slide just to give a bit more detail on SingleStore. So we like to say, in a nutshell, SingleStore is a database to transact, analyze, and contextualize data in real time. That's really a lot of marketing words to say that SingleStore is a general purpose database with a bias for speed. So when I say general purpose, I mean we can handle a variety of different workloads. The first being that OLTP workload, where we can handle really high concurrent writes and point reads. We're able to do this. The most performant way to write is via our pipelines functionality, which you'll see in the demo. But because of our in-memory tier, you can write directly to a table, and you're going to get great insert performance, whether that's great write performance, whether that's a insert, update, or delete. Because we are a distributed SQL database, we can horizontally scale to handle thousands or hundreds of thousands of concurrent queries. And we have built-in high availability and concepts like disaster recovery, point-in-time recovery. So we are able to handle those mission-critical workloads with a lot of certainty and fidelity. The second aspect to this overarching statement is that ability to do fast analytics on your data. So we can handle the transactions, we can handle ACID transactions, and then on top of that data, we can do really fast analytics because of that columnar store. And being a general purpose database, we have support for both structured, semi-structured, and unstructured data types. So you can do analytics on all these different data types all within the one system. The final call out is the ability to contextualize your data. And what we're really getting at here is this whole new world of Gen AI. So a lot of these apps, there's a vector database sitting behind them. And that's something we support in SingleStore. Vectors are a first-class citizen. We've actually had support for vectors since, I think, 2017. And we sort of got a bit lucky that this new wave has hit the world. And having a vector database is a key component to it. So we have support for vector search. We have state-of-the-art full text search. So we have these diverse capabilities that can be done within one database, hence the name SingleStore. Now, a couple call outs is, as I said before, we can be deployed on-prem, in the cloud, or in hybrid environments. And we have that multimodal support. So we can store and query standard SQL data, JSON data, time series, geospatial, text, vectors, and so on. Now, there's really three reasons why customers come to SingleStore. The first is to build with simplicity, and that's one we've really seen a lot lately with this new world of Gen AI, where a prospect may know they need a vector database, but they also know there's the app they want to build has a transactional workload or an analytical workload, and they can already see going forward they're going to need multiple databases to handle this workload. So one way or another, they discover SingleStore and love to build with us because there is that ease of mind or that simplicity of being able to build and handle multiple workloads without having to add specialized databases as you grow and go forward. The second use case we see a lot with SingleStore is to, sorry, is to augment for speed. So that's what we're going to be focusing on today, and it's one of our most common patterns or use cases with our customers. It's that they've got usually a OLTP database that they're very happy with. It's handling that workload, but they want to add or improve the analytics they're serving up to their customers, whether it's internal or external. They know their OLTP database can't handle that workload, or they would have to scale it to a, a lot larger size to handle that workload, and it wouldn't be cost efficient. So what they do with SingleStore is just augment that existing database. So let's keep that existing database. In this scenario, it's going to be DynamoDB. But let's move the data we want to run analytics on across to SingleStore in real time or near real time and serve up our analytics on top of SingleStore. So it's a lot lighter lift because you're not having to do any migration of your application code. It's really just a matter of doing CDC across from the source to SingleStore and then pointing your analytical queries to SingleStore. So it's usually on the OLTP side where the source database is OLTP and we're wanting to add analytics to that. But we also see it on the OLAP side with data warehouses where the data warehouse is great for exactly what they're designed to do, doing those heavy historical reporting, ad hoc analytics. But customers, especially large customers, may have one or two or a handful of internal dashboards where they need extremely fast performance, whether it's sub-second response times with hundreds or thousands of concurrent users hitting the dashboard, or it's just reducing that time to insight, where it may be that in their current warehouse, they have a daily or an hourly batch ETL job to get the data in, and they want to get that down to 5 minutes, 1 minute, as close to real time as possible. So that's usually the pattern we do to augment the sort of data warehouses of the world. But today we're focusing on that OLTP augmentation. And the last use case with SingleStore is to modernize for scale. So it's simply just replacing a legacy database with SingleStore or replacing an architecture which has become very complex. Maybe you started with MySQL, then you added maybe a ClickHouse and a caching layer. Maybe there's a vector database. So that's a situation where you might consolidate those databases and take advantage of SingleStore's general purpose nature. So that's it for the overview. I'll pass it to Sarab to talk about Dynamo and also the two architecture patterns that are possible with CDC to SingleStore from Dynamo.
Thanks, Ben. So this is, I have been working with SingleStore in the capacity of a partner solution architect for many years now. And I've seen the great works from their managed offering, which is a SingleStore ATO solution. And what actually makes a difference, today we're of course going to focus on the DynamoDB aspect of it, is how easy it is to augment any database with SingleStore and get those near real-time analytics capabilities out of it. So before we go into that though, I want to first dive into why customers use Amazon DynamoDB. Right? We see that vast number of customers get started on Amazon DynamoDB. Mainly, it is so easy to get started with. Right? And it is something which you can start with really small, and it will perform at scale. So for customers who have key value requirement where the whole record can be achieved by providing a key, it's a very good use case for Amazon DynamoDB. Amazon DynamoDB is able to get consistent single millisecond read performance as well as write performance. But apart from that, you also get a very high, secure, and resilient solution. When I say resilient, it's globally, you can actually replicate the data set globally in different regions. So in case of even a region failure, you would have the workload running in a separate region. All of this happens with all encryption, right? So the data is encrypted at rest, even at the primary region and the secondary. And in case there is data, because the data would transfer between the two regions, that data is also encrypted. At the same time, that data does not traverse over public internet. You would be able to use the AWS backbone for the data traversal. The team has done heavy work there on providing a very high available SLA, so that customers who have very critical workloads where they need that millisecond latency can take advantage of it. We see very large customers on AWS side, actually taking advantage of DynamoDB. As I said before, it's very easy to get started with. So actually, Amazon DynamoDB is serverless. It basically means that, let's say your team is getting started on any application and you probably don't know what's going to be the reach of the application, what's going to be the schema of the application, what data set are you going to use. You can still get started with Amazon DynamoDB. You don't have to do any capacity management. You can start small. You can even scale to 0. Your data will still be there. And as your application needs more compute cycles or read or write performance, the service will scale as per your request. Even the pricing is pay per request, pay per read request and write request pricing. So you don't have to actually pay for provision servers. So it works out for a lot of applications where teams are starting small, they're building small applications, which might grow into very large scale later on. Right? Apart from this, the whole, because Amazon DynamoDB has a lot of integrations with other AWS services. I would point out, with Amazon DynamoDB, you get the logging, monitoring, and analytic capabilities by integration with the AWS services. For logging, you would be able to get those metrics from CloudWatch. You would be able to also get monitoring metrics from the CloudWatch around how many read units or write units you're consuming. Other use case which we see for customers is at times they want to export all their data from DynamoDB onto S3 or any other AWS service. We provide various capabilities to import and export data from Amazon S3 into DynamoDB, so that customers have that flexibility of taking that data for any downstream application. Right? Like for example, if they want to do analytics on it. One of the great ways in which they would do analytics is, we go into next one is by doing CDC. Why CDC architectures are really important is, DynamoDB is a very good OLAP-oriented database, though it's like a key value database. A lot of updates and transactional processes happen inside it. By having not a batch-oriented, but change data capture-oriented architecture, you would be able to actually get near real-time analytics on that data. So we'll be looking at the first architecture here, which will fit most of the use cases. So what we see here is, we will be using DynamoDB streams and AWS Lambda to get the data from Amazon DynamoDB into SingleStore for analytics. The way in which this works here is DynamoDB has a capability which is also used by their global replication for DynamoDB streams. So DynamoDB streams gets a CDC out from DynamoDB and provides capabilities for customers to leverage it by a Lambda function. When we see here, it's again the Lambda function, the AWS Lambda service will actually poll the streaming, poll the DynamoDB stream 4 times every second to check if there is a message for update or create any record is there in the stream side. Once it finds that message, it will invoke the Lambda function to capture what the change was, and then those can be sent to SingleStore. Remember now that these data set which come into Amazon DynamoDB would be in JSON format. The great capability from SingleStore is they can actually store that raw data in JSON format as well. So now, based on your requirement, you can have custom logic on the Lambda function. That do you want to store the data as is in the raw format on SingleStore, or do you want to actually do a transformation and store it in a relational table format so that you can do more complex queries on that data. So you get the power here by Lambda function to actually change the code, modify the data as you see fit, and send it to SingleStore. And if you want to send the data as is, SingleStore also has capability to do level of JSON-oriented analytical queries as well. Before I point out, this architecture will be catering to most of the customers, but we do see there are certain pros and cons of this architecture. I will also want to cover that here. So the main thing is around time order sequencing. You get the benefit of time order sequencing here. The stream which is coming from DynamoDB will have all the records in order, so you are able to take advantage of that. The other kind of limitation here is on the streams, you have up to 24 hours for these changes from the DynamoDB, which will be stored on the stream. So you have to consume it via AWS Lambda function within those 24 hours, or you have to probably set them to a dead letter queue if you want to process them later. But there is a 24-hour timeline there. And as I mentioned, because of the Lambda function, you get the capability to have any custom logic. You can bring that over to transform the data as it comes in, send it as JSON payload, or send it as a relational table payload onto SingleStore. But again, there are certain limitations as well. So the core limitation in this architecture is on the throughput quota, right? Because the stream is coming out from the Amazon DynamoDB, it has and it is listening in a time order sequence. It's not easy to parallelize it. So to anything which needs to be sharded, you'd lose the time order sequence. Because we want to keep the time order sequence here, there are certain limitations where there are throughput quotas for the DynamoDB table based on the region. So there are different throughput quotas based on the regions you will use on the AWS side. For most workloads, those throughput quotas would not be an issue, but there might be some customers, like if there may be some workloads where you need very high throughput. We'll also look into a separate architecture pattern here. But before moving there, I also want to point out that there is also a limit on fan out. For example, here I have a Lambda function, which is sending data to SingleStore. You might want to send data to any other system as well. So presently, the DynamoDB stream capability with AWS Lambda gives you the capability to fan out to up to 2 Lambda functions when you're working with stream, right? Next, what we will do is we'll look into other architecture, which gives you much more flexibility, but takes away some of the key elements which were advantages when we are working with a Lambda function. So think about customers who have very high throughput need. They don't want any limitation around how much data can come into Amazon DynamoDB. They want very high write throughput, as well as the customers might want to process these for downstream systems in a very flexible way. They want all that flexibility to process them for different downstream systems. In this case, where we use Amazon Kinesis data streams, which has an integration with DynamoDB, you would be able to easily get that data onto Amazon Kinesis data streams, which gives you capability for better fan out. So you get much more fan out into different processes, and also greater retention time. So you have increased your retention storage in the stream for more than 24 hours. Next, I want to point out that you can bring in a connector for a Kafka Connect connector and migrate these records, or move these records onto a managed offering of Kafka, Amazon MSK. So now you get flexibility to bring in other connectors on the MSK side, like other consumers on the Kafka side, to consume these streaming records and have multiple downstream applications take those records and run. You don't have any limits on the throughput. You don't have any other limitations on, because you can scale these as you want, right? Even the Amazon Kinesis data streams gives you flexibility with the storage. Amazon Apache Kafka now gives you flexibility with storage, as well as flexibility with how you want to fan out. With doing that, you lose something. You lose, like, there are capabilities around ordering, which were there for in a single DynamoDB stream. But as we move to a higher throughput system, we have to now kind of check the timestamp of the record to map into the nearest time where these records might have happened. For a very high throughput system, there might be multiple events happening around at the same timestamp. So you have to do that particular part when it comes to mapping the order of the records as they're coming in. But again, this is a no-code architecture. So earlier you had the flexibility to bring in a Lambda function. You were able to, do any transformations you need. You still get to do transformations. I would like to show that once the messages land on Kafka, you have SingleStore pipeline, which is a native feature from SingleStore to read from Apache Kafka in a quick ingest mode and parallelly. But at the same time, SingleStore pipelines also have some transformation features where you can transform the data as it is moving on to the SingleStore usage. So with this architecture, you get the great flexibility of moving in, and you are able to use multiple downstream systems once the messages land on Kafka, and also able to take advantage of no-code and SingleStore pipelines. So these are the two architectures I wanted to present here. And for the most customers, the first architecture would be the easiest to implement. And that's what we Ben, I believe we will be demoing today. But there might be some customers who have very high throughput requirement, which can look into the Amazon Kinesis data streams connector as an alternate tool if they hit that throughput requirement. Yeah.
Beautiful. Thank you very much. All right, so we'll jump into the demo. Just at a high level, we're going to spin up what's called an S1 in SingleStore's Helios offering, so our managed service offering. Rather, it's already spun up. So that comes with 8 vCPUs and 64 gigabytes of RAM. We are going to use that first architecture to discuss. So we're going to be using DynamoDB with Dynamo Streams and the AWS Lambda function. But the streams only picks up newly inserted or newly written records. So the first step in this process for our customers is always to do a batch load or a snapshot load, then begin the CDC process. So I'll show you one way that can be done and then show you just a very simple CDC example or Lambda function, as well as run some queries on both the raw JSON data and another way via pulling out the key value pairs to get a little bit more extra boost in performance. So we'll open that up now. Hopefully I haven't signed out of anything. So I'm in DynamoDB here. Got 3 tables. We're only going to be looking at the orders V2 table. I've just been playing around. Now, before this demo, what I did was upload 1 million records of data. We're looking at purchase data in this data set. Now I took, using the export and streams, I exported that snapshot to S3. It takes on 1 million rows of data. It took a couple of minutes. So I didn't want to have to wait for everyone to have to wait for that here. So we can see that data here. It got uploaded to this bucket orders V2, and then have to nest into a few folders to find where the real data, well, not the real data, the data we want to import lives. So that's the raw data sitting in S3. So first step is to bring that data into SingleStore. So now both Dynamo and SingleStore are a mirror image of each other. So we'll go across to SingleStore and we'll start with a fresh table. So I've just dropped the orders table and I've created the orders table. Running a select everything, you'll see there's no data. Now in the orders table, I've only created one column called JSON data, and it's of type JSON. So we're going to just ingest the raw data into this JSON column. We're not going to worry about pulling out key value pairs. We'll firstly start by just writing the raw data and querying the raw data or the raw JSON data. Now this syntax here is our native pipelines feature. So our pipelines feature is the most performant way to get data into SingleStore. You can currently point it to object storage, so S3, Kafka or Hadoop, as well as a couple other databases, those being MySQL and MongoDB, to pull in data from the source in an extremely performant manner. Now to set it up, it's very simple syntax. All I've done here is name the pipeline. I've pointed to the bucket I was just talking about. So basically, this pipeline is going to be looking at that bucket. And every time a new file gets dropped in there, it'll automatically ingest it into SingleStore. I've passed some credentials so I can access the bucket. They will be deleted after this webinar. I've told the pipeline the source files are of the format JSON. And I've also just mapped the source data to the column in the table. So we've only got the one column and there's only the one key value pair we're concerned about. So we're going to ingest those source files into the orders table. Now you can also point this pipeline to a stored procedure, which can have additional logic to do whatever transformations you need on the data. So that is a method a lot of our customers use to do an additional transformation before writing the data to a table. So I'll create this pipeline and then I'll kick off the pipeline by running this statement here. Now the info schema pipeline errors table holds or logs any errors that are happening. So I see none, which is great. I don't know if I mentioned it, but there's a million rows in the source or in DynamoDB. So hopefully that's what we see over here. That looks good. So we've now got the systems in sync. We've done that batch load of the data. And now there's a million rows in both DynamoDB and SingleStore. So now we can start writing to Dynamo again, and the systems are going to stay in sync. Just taking a peek at what the table looks like. Sorry, 1 second. We'll see there's just the one column, and there's just a JSON object in each column. Nothing crazy going on here. I didn't want to do anything wild in terms of deeply nested JSON for this demo. But just a basic JSON payload. You will notice that it's still got its serialized DynamoDB structure. So there's the key, and then the value is always a JSON object, starting with if it's a string or a number, and then the actual value we're concerned with. You can, and we will share a GitHub repo in the follow-up email. You can deserialize this data. We have a function to do that. So when you load the data, you can run this function to deserialize the data. And then within the DynamoDB script, if you deserialize the batch load, you can adjust the Lambda script to also deserialize the data before ingesting into SingleStore. We haven't done that, so we're just going to have to work with this serialized data. All right, so let's get to the CDC portion. So we've got our table. The first step is to create the Lambda function. So let's come across to Lambda over here. So here's the function. This is just the function I've built. It will be a case-by-case need to be updated for your specific use case, but this really does the high-level aspect of taking inserts, updates, and deletes and writing them to SingleStore. So just passing some connection details and a connection function. And then the core part of the function here is we seek in to get the event. Now, with the stream that's going to be coming in. So that event is a JSON object. Within that JSON object, there's either a event name that is insert modify, or remove. And that's going to determine the action we tell the Lambda function to do. For inserts, we're going to just insert the raw JSON in the SingleStore. For updates, we're going to pull out the order ID, which is the primary key or unique key. And we're going to run an update statement on that order ID. And then for deletes, again, we're going to pull out the order ID and delete any values in the table of that order ID. So very simple function here. Obviously, for specific use cases, you may add more logic to fit your use case. So we've got our Lambda function. Now we need to create that stream that invokes this Lambda function. So jumping back across to Dynamo, I've gone ahead of time and done this just to remove any potential issue doing a live demo. So I'll come across to the test table and just show you the steps that I did to set up the stream. So the first step is to come to this, where firstly on the exports and streams tab on a specific table, and then coming down to the Dynamo stream details section, we're going to turn this on. So this is going to push any item level changes in the table into the DynamoDB stream. Now, from these options here, for my use case, I'm going to choose new and old. So that way, within the stream, the data that's going to be added to each item that gets streamed, it'll include the old image of the row and the new image. So it's really helpful for update scenarios. So we'll turn on that stream. That's good. Now we've got the data streaming. We need to invoke the Lambda function whenever a new record gets streamed. So that's where triggers is going to come in here. So triggers, when we create one, it's going to be used to invoke the Lambda function every time an item is changed. So very simple here, create trigger, choose what Lambda function you want to trigger, and the batch size. And then you would click create trigger. In this scenario, we've already got our trigger set up on the orders v2, so I won't go down that path, but that's the process to set it up. So that's what I've done with orders v2. We can see we've got the DynamoDB stream turned on. We've got one trigger, which is pointing to our Dynamo CDC Lambda function. And you can see with the Lambda function, this is our Dynamo stream and trigger. If I click on that, we can see the trigger. All right, so let's see if it's actually working. So fingers crossed here. So I've uploaded 1 million rows, and the ID value or the order ID values are unique. So there shouldn't be a record with an order ID of 1,000,001. So that's what this query is doing here. Now you'll see this colon notation. That's SingleStore's way of seeking into the JSON object and pulling out the key value pair of interest. So I'll run this query just to make sure we don't have that record. Great. So there's no record in SingleStore. So I've got, I've got 3 very basic scripts here. I've got a script to insert one row with an order ID of 1,000,001. Then I've got a script to update that record and set the order status to test and the total amount to 0. And then finally, a script to delete that record with an order ID of 101. So we'll run through each of the scripts and make sure this architecture is working where we can handle inserts, updates, and deletes. Coming back to SingleStore. All right, sorry. So I'll run the insert script first, be this, or insert a row. So this gets inserted directly into DynamoDB. And let's see if it exists in SingleStore. Great. So we've now got that order ID 1,000,001. You see the order status is shipped, and the total amount is down the very bottom of that pop down is about 417. So let's now update this record and set the status to test and the total amount to 0. So I'll run our update script. All right, so that's happened in Dynamo. Has it flown through to SingleStore? Great. Order status test and total amount 0. So we've got inserts working, we've got updates working. Let's now delete the record and test that. So it's happened in Dynamo. Has it flown through to SingleStore? Yes. Great. So that's the basic flow of how you can do CDC. The real, I don't know if bottleneck's the right word, but creating the Lambda function is where you'll need to write the code. Now we do have in our GitHub repo code you can copy, but you will have to adjust it for your specific data set and use case, specifically just seeking into the right key value pairs to do your inserts, updates, or deletes. Okay, so let's just look at a little bit of running analytics in SingleStore. So we'll start first with just querying the raw data. So it's really been a large investment on our engineering team's part for the last year and a half or two to really improve the performance on analytics. And we actually currently have a product that has native ingest from Mongo and the ability to query your data still using Mongo syntax. On that product, we call it Mongo Kai. We tend to see around a 40 to 100x performance boost running the same Mongo queries on top of Mongo, except pointing it to SingleStore. So that's really the road we're going of making it easy to have this augmentation play where you really like your transactional database, but you want to get a boost in analytical performance or start adding that to your application. So let's run a couple queries, just querying the raw JSON. This query here, we're just finding the proportional of revenue attributed to each city. So we're doing a group by on the city, and then we're summing total amount spent at the city level, and then we're getting the percentage. So city X spent $100, but there's $1,000 spent system-wide, so they account for 10% of revenue. So to do that, we're using a window function to do the total spend across all cities. So we'll run this query. So that took 139 milliseconds as a round trip. So that includes the network latency for the network traffic from sending it to SingleStore and getting the result back. You see if you run it again, we got a performance boost on that second run. This is a key reason or key way SingleStore gets really fast query performance. We're not caching the result of this query, but we are caching the query plan. And when we see a query plan for the first time, we'll convert it into low-level machine code, which has additional optimizations. Now, the next time we see that query, we'll use that stored and optimized query plan to run subsequent queries. So you'll see on the second run of a query, you'll get a boost, second plus runs, that is. That's even if, and I'll show you on the next example, even if we change the parameters, that's not a problem. The only thing that's stored is the query shape. So it's better, I'll show you on the next example just what I mean by that. For this query here, we're doing getting a little more involved. We're using common table expressions to essentially get the top 3 customers within each state based on their total spend. So we filtered out orders that have been cancelled, and then we're grouping by on city and customer ID and getting a total amount spent. Now, with that result set, we're then ranking the customers based on total spend. So we're using a window function here with the row number function to, within each city, rank the customers from 1 to X, 1 being the highest spending, X being the lowest spending. And then finally, with that result set, we're just filtering at the city level to only return the top 3 customers in each city. So I'll run this query, 181 milliseconds. If we run it again, we should see a boost. So a little bit of a boost down to 134. Now, the thing I was referring to with the query plans, if we were to change this to now processed or arrived, that doesn't affect, you won't be punished. We'll still use the same query plan. So these parameters are parameterized in the query plan, and it's just the query shape that matters. Or if we change this to 5, we're still going to use that cached query plan and get that performance boost. So you see it's down around 140. If we do 103. So we are getting a boost there because we're getting additional filtering. But we are using that cached query plan to get that extra performance boost. Just to iterate on that, we're not caching any results. We are caching the low-level machine code that has the query plan stored to execute this query. So that's how a lot of our customers will query their data, their NoSQL or JSON data. Now, if you wanted to get an extra performance boost, you can pull out the key value pairs, or maybe there's certain queries where there's a key value pair that always gets queried, and it will get boost across the board if you just pull it out into its own column and query it using sort of standard SQL or relational data. In this scenario, there's really two ways to go about this. You could update your Lambda function to pull out the key value pairs of interest and insert them into their own columns. Or you can use SingleStore's persisted compute columns. So what happens here is our persisted compute columns, just under the hood, pull out the key value pair of interest and store it in its own column. So that's what we've done here for the 4 columns of interest: customer ID, total amount, shipping address, and order status. So I'll run these four commands and then show you what the data looks like. I'll wait for this to finish. All right. So just looking at the orders table again, we see now we've got 5 columns. We've got that raw JSON column, and then the 4 columns that we've pulled out. Now, even if we were, actually, I might show you, have I got it here? I'll just show you how it works under the hood after we run through the analytical queries. But running the same queries that we ran above, just using the columns directly, you see the syntax is a lot easier to read, but we should also get a performance boost. So down to 19 milliseconds, I think it was around 70 before. And then for the top 3 customers, running it twice, down to 84 milliseconds. So not necessarily something you have to do, but if you are, especially when you get the larger data and more deeply nested data, you can see a performance boost by pulling out these key value pairs. And an easy way to do it is via these persisted compute columns. Now, the good thing about the persisted compute columns is you don't have to change that Lambda function. So if we go back to our CDC, very simple CDC example, we've got no rows for this 1 million row, 1,000,001 order ID column. Let's go through that same flow of inserting and updating. So we'll insert the row, and then we'll, hopefully it's come through. Beautiful. So you see automatically under the hood, we've pulled out the key value pairs that we created persisted compute columns for. Now we'll do an update, and we'll also see that even without directly touching these last 4 columns, the order status and total amount will adjust under the hood. We'll run the update script, requery the table, and we see order status is now test and total amount is 0. So that's really all I had for you today in terms of the demo. It was on a small scale in terms of 1,000,000 rows, 1 table. One thing to call out is SingleStore is very comfortable and performant when it comes to joining between tables. So that's certainly not a limitation. You won't have to do any denormalization of your data and get it all into 1 table. We're very comfortable and good at doing joins across tables. And 1,000,000 rows is a very small data set for SingleStore. I'm working with not necessarily large companies, but companies who have 100 million billion rows of data, and they're getting really fast analytical performance when joining that particular table to 2, 3, 4, 5 tables for their customer-facing dashboards. I think that might be it. Do we want to stop for questions, or do we want to do the wrap-up slides before the questions?
All right. Thank you so much for the demo. We actually, Akmal, do you think that we have any questions that can be taken now?
I think there's a couple of questions, Ben, about the GitHub repo link. You've posted that already in the chat, or is that coming later?
Yes. Yes, I have posted it in the chat, but sometimes what happens that if people join a bit late, they just don't get it. I mean, I don't know why that is, but yeah, I'll post it again.
Yeah. And I think normally you send it out with a follow-up email anyway. So anyone that's registered will get links to the assets. So that I
Yeah.
think should be
Yes.
good. Um, it's Ben, I don't know if you and Sarab, there's a couple of questions answered there, which I tried my best. You may want to just review those. Anything you want to add to what I've said there, please go ahead and do so. But I think let's see. Okay, so there's a question there. I think you can see from, forgive me if I mispronounce this. Is it Akar or Akar Solomon? It says, so SingleStore is like a one-stop workbench for a multitude of languages. Ben, I think probably you can best answer that.
Yeah, I describe it as a general purpose database. So yes, we can handle a variety of different workloads with good performance. So uh, typically we see in the industry, customers or prospects, as their demands for the application grow and they start to add different workloads, they need to add additional specialized databases to handle these edge cases. But the most common one right now is adding Gen AI to your application. Whatever you're currently using may not be able to handle that. So you have to go find a vector database, stitch it together, and now you've got two or more databases. SingleStore has this diversity or rather this ability to handle a diverse number of workloads. So you don't need to have these specialized databases. We can handle, I'm not going to say every use case in the world, but we can handle a key majority of use cases to really simplify you building applications.
Yeah, I think it's that what we're good at is preventing the database sprawl. So if you've got multitude of databases that you're already using, SingleStore can help consolidate all of those. And as Ben was saying, the OLTP, OLAP, unified storage, plus all the multi-model capabilities, geospatial, time series, the JSON support, which you saw today, for example, Kai, and lots of other things that I think really makes it a standout product and beneficial for you if you're a developer, because one product to learn, good for you if you're from the business world because you save money. You don't have to pay licensing fees for multiple products. You get better return on investment, lower total cost of ownership. There's a question there from Sachin. It says, would this work with real-time recommendations?
I guess it depends how real time. Are we talking, do we allow sort of a 300 millisecond latency from the record getting created to it populating into your recommendation? If the answer is yes, that's fine, then yeah. So that was a key call out. I may have kept saying real time, but near real time, sort of sub-second real time from event to being able to query it in SingleStore is probably a more fair representation.
Yeah, and I think, Saurabh, you might have something to say on DynamoDB there. So, I mean, part of the reason that Amazon built that was precisely because it's a question of not, I mean, if you're using it, say, for, the actual Amazon website, let's say you've got someone with a basket of items, you do not want to lose that customer. So that was, I think, some of the background story of why Amazon DB was built precisely for scale and speed and keeping the data. And that could be very useful as well for, I think, these high, requirement environments in terms of throughput and latency and
yeah. So DynamoDB is really great when it comes to low latency workloads, right? So the millisecond latency is the key aspect where customers like to use it. But I would like to go back to the question asked by Sachin that yes, SingleStore has capabilities to do a vector search, which can be tied with large language models now, or even machine learning models to get that recommendation out. So, and the great capability here, which we spoke about, was the near real time. Ben, it's really great that we try to keep that realistic. I know that there are some customers who want to, need that real time. Like there are some financial service customers who need probably a very focused application for real time. But a lot of customers, when they talk about real time, they're talking about near real time, where you can still get a recommendation in sub-second workloads. And SingleStore can actually do that by piping the CDC records from Dynamo to SingleStore, and then probably using the vector capability. I know that Akmal, you have done a lot of these sessions around the capabilities around the vector search and bringing in AI recommendations for customers. I believe they will be able to tie those things together, get those recommendations, and yeah.
Yeah, great. Apologies, I was just trying to find a resource. Someone was Peter asked a question about graph. We don't support graphs if you're thinking of something like Neo4j type of graph. No, but we do recursive common table expressions, and that is a way to be able to handle a graph-like processing. And I was just going to post a link in there for you, Peter, for an article I did on the London Underground and finding the best routes using that. So that might be useful. There we go. Dismiss that. Okay, I think we're almost at the top of the hour. You want to just I think maybe you want to announce the winner and just to remind us of the next event. So I'll hand over to you.
All right. Thanks everyone for joining and your amazing questions. Thanks to the speakers for taking out the time and doing this webinar with us. So, just quick notes before I announce today's raffle winner. We have amazing sessions that you can see on your screen that are coming up. So, I think this slide is not exactly updated. We have like today's session has been highlighted. So if you can just hit refresh, Akmal, that would be good, like whoever is sharing the screen. Or you can just present the initial slides if that's the thing, like that had the correct. Yes. So thank you so much. Tomorrow we are presenting Beginner's Guide to RAG Evaluation with Professor Tom Gay. He is from University of Colorado, and this is one of our most popular sessions. So feel free to tune in, and I hope to see you there. On August 29th, we have how to use SingleStore for auto scaling, and on September 5th, we have how to talk to your SQL data with function calling. So if any of these topics are interesting to you, RSVP right now, and I hope to see you all there. So moving on, announcement that you've been waiting for. Today's raffle winner. It goes to Mr. Prakash Sinha, who's the VP of AI here at JP Morgan India. So if that's not you, do not give up. We are going to announce one more AirPods winner by the end of the day for anyone who has tried out today's demo using the code that was given in the chat. So sign up at the link that's there on your screen. You can just go to the website by scanning the QR code and just log in for a free trial, load your data, and create a workspace and be eligible and be entered to win. Thank you again for joining, to our speakers and our audience. Your time and energy really matters to us, and I hope you learned something new today, and I hope to see you all in the next session. So thanks again and take care, everyone. Bye-bye.